We only discovered dark energy 14 years ago, the accelerating expansion of the universe. So it's no surprise that we don't yet fully understand dark energy. Dark matter was only conceived a few decades ago. So again, we don't yet really know what dark matter is, but we've not been investigating it for very long. I mean, in hundreds of years, who knows what we will know? We might have a full inventory of what's in the universe and how everything behaves. So we will know a lot, but we won't quite know why it all happened and why there's something rather than nothing. Why are there any mathematical laws of physics rather than just nothing at all? I don't know that we'll ever understand that. Scientists are only well aware of 4% of the universe. That is, we understand pretty well the nature of 4% of the universe, the stuff that is made of atoms. 96% of the universe is made out of dark matter and dark energy. And although we know that they are present, we don't know what their detailed properties are, or why they are there, or what exactly is going on. So, in the past couple of decades, there's been a true revolution in our understanding of the universe. What we used to think of as being everything is actually only 4% of the pie. If you think of a pie with slices, 4% consists of the normal stuff of which we are made.
But this is fascinating.
It's fantastic, that's right, yeah. And so you can see that our view of the universe as scientists changes. And that's a strength of science. Scientists are not afraid to say that they used to be wrong. Their view of nature was incomplete. We love finding new things and coming up with what we think is a more complete description of nature. That's the fun of it. We don't take anything as an article of faith, other than perhaps the existence of the laws of physics. But everything else we try to understand from those laws of physics. And with time, we're coming to a better understanding of the laws themselves. For example, I said that there are 4 fundamental forces. But in fact, in high-energy colliders, like the Large Hadron Collider, they're smashing particles together so much, with such great force, they found that the electromagnetic force, what holds atoms together, is very similar to, and in fact the same thing as what's called the weak nuclear force, which is a very strange force having to do with neutrons. They behave the same way when particles have very high energies. So in a sense, there's only 3 fundamental forces. And there's a suspicion that the electroweak force and the strong nuclear force, which is what keeps protons and neutrons together in a nucleus, they might become the same force at even higher energies, leaving a grand unified force and gravity. And then in the theories of everything, string theory is one attempt to do this. They are trying to unify this grand unified force with gravity, meaning that fundamentally there might be just one concept, one force, and these 4 forces we see in today's low-energy world are simply different manifestations of one fundamental concept. That's the goal of string theory, is to figure out in its most basic way how the universe works.